Have you ever just stopped and really thought about the fact that every star we see out there, even our own sun, well, every star is on a one-way trip.
It's
They eventually run out of fuel.
They're light dims.
Yeah. And they basically just become these silent kind of remnants just hanging out in space.
It really is a humbling thought, isn't it, to
Yeah.
consider that every single star we've ever seen is destined for that same fate.
It really is. It makes you feel pretty small, you know?
It does.
Just thinking about the grand cosmic scale of things and our own little blip of existence and all of that.
Absolutely.
But you know what's amazing?
Hmm.
We recently found this really interesting star system practically right in our cosmic backyard.
Oh, yeah, I know what you're talking about.
And today we are diving deep into this system
A deep dive it is.
because it has a lot to teach us about one of the most incredible events in the universe, a Type Ia Supernova.
These events are so crucial to our understanding of the universe.
They really are. And what's even cooler is this isn't just some theoretical concept. This is about understanding how the elements that make up everything around us, even us, were created in these cosmic explosions.
We're talking about the very atoms that make up our bodies, our planet, everything we see and touch.
Exactly. So we've got some really fascinating details about this discovery and this binary white dwarf system.
And what their eventual fate can tell us about how stars live and die.
Exactly. So what we really want to understand is what makes this discovery so important. How does it change what we know about Type Ia supernovae and the whole life cycle of stars?
I think it's safe to say this is about as close as we'll ever get to witnessing a cosmic explosion in action.
Right. And the fact that it's happening relatively close to us in galactic terms.
Right.
It's like having front row seats to this incredible cosmic event that's still billions of years in the making.
Absolutely. It offers us this really unique window into the processes that drive stellar evolution and these powerful supernovae.
Okay, so let's get into the specifics of this star system.
Okay.
It's got a bit of a mouthful of a name. WDJ 1810058.67 plus 311140.94.
Quite a name.
I think we'll just stick with calling it WDJ for short.
Sounds good.
But what's really mind-blowing is that it's just 150 light years away from us.
In cosmic terms, that's like right next door, practically our neighbors.
I know, right? It's amazing to think that something so incredibly significant is happening so close to us on a galactic scale.
It really puts things into perspective.
It does.
Our galaxy, the Milky Way, is about 100,000 light years across.
Wow.
So 150 light years is really a tiny distance in comparison.
Yeah, that makes it seem even closer.
It really highlights the incredible scale of the universe we live in.
And to make things even more interesting, scientists have actually calculated that these two white dwarf stars in WDJ are set to collide in about 23 billion years.
It's a timescale that's difficult for us to even fathom, isn't it?
Totally. It's way beyond the projected lifespan of our sun.
And certainly beyond any conceivable future for humanity as we know it.
Oh, yeah. But here's the twist. They're not actually going to reach that collision point.
Right.
They're going to go out with a bang long before that.
A much more spectacular bang.
Yeah, a Type Ia supernova, it's almost like a cosmic plot twist.
It is.
This predicted merger is going to be completely overshadowed by an even more powerful event.
Because these two stars are so close to each other,
Right.
their gravitational pull is constantly increasing.
Uh-huh.
And what's going to happen is that one of them will actually start to steal matter from the other,
Oh, wow.
and it's going to keep pulling in more and more mass
All right.
until it hits a critical point and triggers this enormous explosion.
A supernova.
Exactly.
That's wild. So let's break down exactly what these white dwarfs are. Our sources describe them as stellar embers, which is such a cool visual.
I love that description.
Yeah.
Because it really captures the essence of what a white dwarf is.
Yeah.
It's like the leftover core of a star
Mm.
that's burned through all of its fuel.
Mm.
So stars like our sun, or even up to about 8 times the mass of our sun, they go through this long phase where they're fusing hydrogen into helium in their core.
That's their main sequence life, right?
Sure. Exactly. That's when they're really shining bright.
Okay.
But eventually they run out of that hydrogen fuel.
Mm.
And when that happens, they start to shed their outer layers.
Okay.
And what's left behind is this incredibly dense, super compact core, the white dwarf.
So they're tiny, but they're packed with so much mass.
They can be about the size of the Earth or the Moon,
Wow.
but they can have the mass of up to 1.4 suns crammed into that small space.
That is some serious density.
It's almost impossible to imagine.
I know, it's like trying to picture squeezing the entire mass of our sun
Right.
into something the size of our planet.
It's mind-boggling. The gravitational forces involved are immense.
It's hard to even comprehend, and there's this critical limit to how much mass a white dwarf can handle.
Yes, exactly.
The Chandrasekhar limit is...
That's right. It's about 1.4 times the mass of the sun.
Okay.
And if a white dwarf somehow manages to exceed that limit, either by pulling in material from a companion star
Okay.
or through a merger, gravity basically wins the battle. And it triggers this incredible Type Ia Supernova explosion.
So these Type Ia Supernovae are pretty important events in the grand scheme of things. Our sources called them spectacular explosions and even measuring sticks for the universe.
They're crucial to our understanding of the cosmos.
In what way?
Well, one of the amazing things about Type Ia supernovae is that they have this remarkable consistency in their peak brightness. And this allows astronomers to use them as what we call standard candles,
Okay.
which means we can use them to measure distances to galaxies incredibly far away.
Oh, wow, I see.
So by comparing how bright a Type Ia supernova appears to us here on Earth
Right.
to how bright we know it actually is,
Uh-huh.
we can calculate the distance to the galaxy where it occurred.
Wow, so they're like cosmic mile markers.
Exactly. They're one of the key tools we use
Yeah.
to map the vast distances of the universe.
That's incredible. And I read that they also play a vital role in creating the elements that make up everything around us.
Oh, absolutely. These explosions are responsible for spreading heavy elements throughout the universe.
Okay.
So during their normal lifetimes, stars fuse lighter elements like hydrogen and helium into heavier ones. But when a star goes supernova, all those newly created elements get blasted out into space.
Okay.
And these elements are the building blocks of everything we know.
Wow.
Planets, new stars, and yes, even us.
So we really are stardust, as they say.
We are quite literally the product of stars that lived and died billions of years ago.
That's incredible. It really makes you appreciate our connection to the universe.
It does. It puts things into perspective.
Now, for a long time, scientists have theorized that binary white dwarf systems like WDJ are responsible for a lot of these Type Ia supernovae.
Right.
This discovery seems to be a major piece of evidence supporting that theory.
It is for years astronomers have suspected that two white dwarfs orbiting each other could eventually merge, or one could pull enough mass from the other to exceed that Chandrasekhar limit we talked about.
Right.
And that would lead to a Type Ia supernova.
And that makes sense given how common these binary white dwarf systems are.
Exactly. As astrophysicist James Monday pointed out, the companion, being a second white dwarf, is a natural explanation for a large fraction of Type Ias, because this type of system is quite numerous in the Milky Way.
But there was a problem with that theory, right?
There was.
What was it?
Well, the calculations seem to suggest that it would take longer for these white dwarfs to get close enough to trigger a supernova
Okay.
than the entire age of the universe,
Oh, wow.
which didn't quite add up.
No, it doesn't.
So even though we knew about these binary white dwarf systems,
Right.
the predicted timelines for them to spiral inward and cause a supernova just didn't seem to align with the age of the cosmos.
That is a bit of a cosmic conundrum.
It was.
But this new discovery of WDJ changes things quite a bit.
It does.
What makes this system so special?
The key factor here is how incredibly close these two white dwarf stars are to each other.
Okay.
They're separated by just 160th of the distance between the Earth and the Sun.
Wow, that's incredibly close.
It's an astonishingly tight orbit for objects with that much mass.
I bet.
When James Monday first saw the data,
Uh-huh.
he knew right away that they had found something truly remarkable.
Really?
He said, discovering that the two stars are separated by just 160th of the Earth-Sun distance, I quickly realized that we had discovered the first double white dwarf binary that will undoubtedly lead to a Type Ia supernova on a timescale close to the age of the universe.
So that close proximity is speeding things up quite a bit.
It is. Their orbital dance is causing them to lose energy much faster, which means they'll reach that supernova stage much sooner than we previously thought possible.
Still billions of years in the future, though, right?
Oh, yes, definitely. This is still an event that's far beyond our lifetimes.
Okay, good. Just checking. I wasn't planning on having to evacuate the planet anytime soon.
Not to worry, this is a cosmic ballet that's unfolding at a pace we can barely grasp.
And the source also mentioned that the combined mass of these two white dwarfs is about 1.56 times the mass of our sun. And they have an orbital period of just over 14 hours.
Yes, those are really important details.
How so?
Well, the combined mass, being over that Chandrasekhar limit, tells us that a supernova is pretty much inevitable.
Okay.
And that short orbital period of just over 14 hours highlights just how close they are
Ah.
and how rapidly they're losing orbital energy.
It's incredible to think about this pair of white dwarfs silently circling each other for billions of years and then bam, a supernova.
It's a reminder that the universe is constantly evolving and changing.
Even on timescales that seem unimaginable to us.
Absolutely.
But I think what's really exciting about this discovery is what it means for our understanding of Type Ia supernovae.
Right. It provides the first concrete evidence directly linking these supernovae to binary white dwarf systems.
So before it was mostly theoretical, but now we have a real-life example.
Exactly. It confirms what we've long suspected, but haven't been able to directly observe until now.
So it's kind of like finding the missing piece of the puzzle.
It helps us make sense of these incredible events and understand their role in the larger cosmic story.
And this discovery is also going to help scientists find more of these pre-supernova systems in the future.
Absolutely. Now that we know what to look for,
Right.
we can refine our search strategies and potentially uncover many more of these systems out there.
And that will give us even more data to work with.
Exactly as James Monday put it. With this discovery, we found the first double white dwarf that undoubtedly will explode as a Type Ia on our galactic doorstep.
Mhm.
We can now, in fact, credit a few percent of the rate of Type Ia supernovae in the Milky Way to double white dwarfs, which before was 0.
That's a huge shift in our understanding.
It is. We've gone from theoretical possibility to observational confirmation.
So to wrap things up, we have this fascinating pair of stellar remnants, essentially our galactic neighbors,
Right.
locked in this slow but inevitable dance towards a spectacular supernova explosion.
And this event will not only light up the cosmos, but also help us learn even more about the universe, its size, its expansion, its very evolution.
It really is a mind-blowing discovery, and it makes you wonder what other incredible stories are unfolding out there in the vastness of space.
It does. It underscores the dynamic and often unpredictable nature of the universe.
Absolutely. So if this deep dive into the world of white dwarfs and supernovae has left you with a sense of wonder or even sparked some new questions, we'd love to hear from you.
Yes, we'd love to hear your thoughts.
Share what surprised you the most or what you'd like to explore further in the comments below.
It's always great to hear from our fellow space enthusiasts.
And if you enjoyed this cosmic journey, consider giving us a like or subscribing to the channel to join us for more deep dives into the mysteries of the universe.
We'll see you next time.
See you then.